Alrighty, let's get started. The review today, we are just going to focus on 8.1, 8.2, and 8.3. And then tomorrow and the next day, we'll focus on the whole thing and try to put it together. It's just been a really long time since we talked about 8.1, 8.2, and 8.3. So it says, suppose x and y vary inversely. Now, I would stop right there because I want to write down that inverse variation equation, which is y equals p over x. We can start thinking about how all of that works. It says, write a function that models each inverse variation, describe the graph of the function, and find y when x is 10. Okay. So what do you suppose I'm supposed to do with x equals 3 and y equals 2?
Plug them in.
Good idea. What is
K
that
equals
equal to?
6.
Yeah, you've got to have k. Now what is that for? What do we use that for?
I don't know. Yeah, well, if I find K, then you can find X.
Okay,
Plug in the
what do
K.
exactly. We have to plug in the k. Put the 6 where it's supposed to go. That's our job. Get that inverse variation equation. That's the first step. I know it seems like there's multiple steps there, but we're really just finding k. So write a function that models each inverse variation. Did that. We've done that. Got the picture. Where we go. Y equals 6 over x. Describe the graph. What does that graph look like?
Yeah, it would be like, it would be kind of wide because it's a 6, but not too far away from the middle.
What's it? You said it would be kind of wide.
2 lines that are going in the first
Lines?
No.
Hyperbola. Hyperbola. And yeah, Eli's on, you're giving me more detail than I really needed. I know, you were telling me the 6 is going to pull it away from the origin. That's exactly what's going to happen. But really, we just wanted to know, what does it look like? What it is. Could you tell me which quadrant?
First 1/3.
First and third. We have positive 6 up there.
I would remember the whole So you read it like the Japanese books. Right to the left, and then down the right.
European. Counterclockwise.
Yeah.
1, 2, 3, 4.
And you start in the one that you use the most.
All right, we're not quite done. It says we're supposed to find y when x equals 10. So what should we do? Exactly.
Why?
10 and 6/10. And decimals will be just fine with variation. If you want to reduce it to 3/5, that would be all righty. So you think you can do 2 on your own?
Yeah.
Give it a try. Looking good. What was K? How does this look? Hyperbola. It is. Or negative 2/5. Like I said, with variation. Most variation equations will have to work like that kind of thing. So decimals are okay. All right, number 3. Ooh, this one looks more challenging. When x equals 4 and y equals 5, z equals 8. Okay. Write the function that models the following relationship. Z varies directly with x and inversely with y. What's direct mean? I mean, no one has to have a k in it. Whenever we see varies. Z equals kx. Now where do we go? Plug in the numbers they gave us. Sounds like, I mean, it was right there this time. Here are the numbers. Use them. So 8 equals k times 4 divided by 5. Find the k it in. Yeah, that was the whole reason we did all that math. So z equals 10x over y. All right, they have any backup plan here, a part B? Oh, done. Oh, done. So we get it written and you stop. All right, we got to scroll up, erase and scroll up. So
I don't know.
second here.
I don't know. I just learned so many things each day. Like my parents asked me to the dinner table, what did you learn today? I just talked about math. 8-3.
Yeah,
All right.
I learned about section 8.
Yeah.
Yeah.
Gives a total synopsis. All righty. This one says write an equation for the translation of y equals 4 over x that has the given asymptotes. Oh my goodness. This all comes from this. It is. But you have to remember that formula. You look at it at first question and say, what on earth am I supposed to do here? All right. So if these are the asymptotes, x equals 0 and y equals 3. Where's the 0 go? H. Where's the 3 go? What? There it is. Huh? Remember y equals a over x minus h plus k. So in 15, it looks like it's going to have a little more meat to it. What do we have in our denominator? X plus 2, yep. And then hang out back. There it is. So, 8-1, direct, inverse, and joint variation. 8-2, just translating basic y equals a over x minus h plus k. 8-3, there was a lot of stuff. Lot of stuff. Do you remember any of the stuff? Well, starts with the pods. Start on the bottom. Is it going to cancel? Is it a whole or is it an asymptote? It's an asymptote. It's not going to cancel, so that's a vertical asymptote to x equals 2. Don't have any holes because nothing's going to cancel here. Since we're talking about stuff that's not on our graph, let's go after horizontal asymptote.
This one is 1. The x over the x 1.
Remember, there were two ways to do this. You could think of it as infinity. If you put infinity in for x, it would be infinity over infinity, which would just drop out, cancel out, and be 1. Or you could memorize, if the degree of the top is less than the bottom, then it's y equals 0. If the degree of the top equals the degree of the bottom, you do the funky fraction in front. And then if the degree of the top is greater than the degree of the bottom, then you don't get it. So you either think through it with infinity or you memorize those pieces.
Wait, so the degree on the top is
The degree of the top is
It's x
greater than
and
the degree
x.
of the bottom, you don't get one. It's not.
If there was like a 2 in front of that x, it's still x and x, and then you just do correct.
Are you okay with horizontal asymptotes? All right. So that's the stuff that's not going to go on our graph. So let me go ahead and get that on here. Not there. Hopefully not here. But why do I say hopefully?
Sometimes it rocks.
Let's do that. All right. Well, that's the stuff that's not going to be on our graph. Now we want the stuff that is going to be on our graph. Remember, for x-intercepts, pardon me, frog problems, y needs to be 0. Now, notice we have taken all information we can possibly take out of the denominator. So it just makes sense that now we have to start studying the numerator for this part. If there's a 0 on the top, this is going to be a 0. How do we get a 0 in the numerator? There it is. -1. And then we would want to know the y-intercept, which which is just a matter of putting a 0 in for x, or coming up here and saying, well, that's going to be 0 plus 1, and that's going to be 0 minus 2, so that's 1 half. And that stuff that is on our graph. Oops, negative 1, 0, not positive 1, 0, and that goes back on. We have enough for the left branch of this hyperbola. We just need to know how close is this getting inside to the origin there. So
Yes.
this is good. But yeah, the other side. Now you certainly, pardon me, you certainly could just put this in your calculator at this point. We're not taking the calculators away from you for the test. This is kind of a little bit, so you might just want to do this one by hand and say, I already know what's going on this side of 2. I need to know what's going on that side of 2. So if I put 3 and 4 in there, then that'll be enough. So 3 plus 1 is 4, and 3 minus 2 is 1, and 4 divided by 1 is 4. Nice little point there. Put a 4 in here. 4 plus 1 is 5. 4 minus 2 is 2. 5 halves is 2 and a half. And that's as close in as we get. Again, you need arrows to show that these go forever. You need to make sure that it does not look like it's going to hit or cross your asymptote. Keeping in mind, unfortunately, maybe just maybe, you might actually cross the horizontal asymptote at some point. And that's why it's always good to put it in the graphic calculator, just to make sure. But for the graphic calculator to know what to do, you have to tell it, hey, all this stuff up here divided by all this stuff out here. That's a lot of points there. Well, there's a lot of stuff going on. All right, 28 looks like a monster.
Oh, gee.
Any thoughts?
I think.
We better factor that.
Yeah.
How do you factor x squared minus 9? Difference of 2 squares. Oh, it does. So what does that mean to us? It is a whole. Now, myself, I occasionally forget to put the whole down if I don't find it right now. So I would figure out where it is. And how we do that is we actually do the canceling. So cancel out the x plus 3. And you get y equals x minus 3. Now put your negative 3 in there. And you will know where that hole is right now. And I go over and put it on because, like I said, I have a tendency to forget at the end. Get those holes on there. Get carried away with all my asymptotes and all the stuff I know, and before I know it, I've made some solid hyperbolas. All right. Vertical asymptotes for this bugger. We just took everything out of the denominator by doing that hole, didn't we? While we're talking asymptotes, horizontal.
Not. Look at the top. The bottom.
Always about the degree.
It's probably going to be infinity. Yeah, it's just so much.
You don't get one.
Got it right,
Infinity
guys.
is not a limit. It's not a number that cuts you off. Infinity keeps
Thank you.
going forever.
Did
Well,
you guys?
that's-
I know. Did you guys hear that? I
that's a
said
bummer.
not.
I know. That's a bummer. That's a lot of stuff that we would hope to have information for that we don't. So all we know so far is that this has a hole at -3, -6. All right, well, let's find some stuff that's supposed to be on our graph. We just use the denominator to find everything that's not going to be on our graph because dividing by 0 is bad. If we want this to come out to be 0, the top has to be 0 because 0 divided by something is 0. So we go to the top of our fraction and say, what's going to make the 0?
Okay. That's 8 by 6 for x.
It is,
Okay. So I think it's going to be negative 3 and positive 3.
except
0.
what was negative 3? It was a whole.
Oh,
So we can't use that. Yeah, it's out of the domain because it was a whole.
Wait, so do you go back to the original equation and do this? Or do you go to the...
Oh, I always go to the factor.
Yeah, it would be
Always
easier
the factor.
without the canceling.
Right. And then think through it. How about the y-intercept? Look at where I put the 0.
0 plus 0.
Negative 9 divided by 3. With zeros in all the positions for the x's, that's what the y-intercept did. You put in the opposite, you put the 0. So it's the x that's 0. You go up here, 0 minus 9 over 0 plus 3, that's negative 3. So these are some points that are on our graph. Which means this must be a pretty weird graph. Now we could sure put some more points in there because my worry right now is that this might be a straight line with a big hole in it. It's quite possible that's what's happening. I plop it in. Let's see. I mean, if it is, we have enough points already. Now, why do I think that? Well, that's some points. Give me a minute. Yeah, and remember when we canceled, we got x minus 3? Oh yeah, definitely put the parentheses. Remember, always parentheses in the top, parentheses on the bottom. There it is. Well, look at that. Our graphing calculator doesn't know to put a hole on there.
So we would have got that wrong.
Exactly. That's why I said right as soon as I know there's a hole, I find where is it going to be. They're just sitting there working.
It's a slow function.
Oh, it's stuck. Stick it.
That's a new problem.
Just go check to make sure there's not something hinky down below here. It just needed a minute. Let it catch its breath. There it is. Now, obviously, I have a little table thing and say, okay, well, I already have a bunch of points on there anyway, but I might as well put a couple more on here since this was a line. -1, -4 would be a good one.
Wait, let's see if on the table it shows the whole.
It should say error since
It
this one
does.
was an integer.
Negative 3 here.
So you still might catch it, you know, if you have your table in the right spot. And since it's a test, you should be. There you go. Triple check. All right, let me move that monster up.
Double check. Yeah, good.
That one looks interesting. What you thinking? We'll factor in? Okay. Give it a try. Not a perfect perfect square trinomial, right? Now with the -4 in the back. It's fine. Very glass and took. Do you have any holes? Where are they? Horizontal asymptote, since we're thinking about it. basically have 5, which is spitting in the ocean over infinity. And this, as this gets bigger and bigger and bigger, this will approach 0. In fact, use an arrow to show approaches. Stuff not on the graph. Get it on there. Big in mind, but maybe, just maybe, it might cross. That's where that was. Stuff that's on the graph. Let me check. Is there any way to make a 5 a 0 without magic point?
You tried really good. You put a 0.
Think
You multiply it by 0.
Zero. We can't. There's no X up there.
What if you multiply the top and the bottom by 0?
Yeah.
What you do? It's just a 5 up there, so you can.
Can't do it. There's no X. There's no way for us to manipulate it. Can't happen. All right. Y-intercept 0 something. Should have had an equals y, by the way. Somebody must have accidentally cut that off there. All right, well, we have the point. 0, negative 1. Oh, yeah. What do we need to be careful of when we punch this in? There's a lot on the denominator there. We better put some parentheses around that. Make sure that calculator knows all of that gunk is together. Let's take a look. We're going to need some points. So let's see. We've got to go beyond. We got a negative 4 for vertical asymptote. Good news. We did that right. Wouldn't be an error there if we hadn't. So negative 5 and negative 6 are both good numbers. But is this actually going to cross the asymptote? Because it's already really close. Looks good. Looks like we're staying above. So at least for our negative 10 to 10 window, and that's all we need to graph, it is going to stay above that asymptote. Good. That's good news.
Good stuff, guys. Great stuff.
Middle section, we need stuff between negative 3 and 1. Negative 3, negative 1.25. Negative 2, negative 0.83 repeating. Negative 1 is also negative 0.83 repeating. And we already had that little 0, negative 1.25 there. Let's see. Again, make sure it is approaching those asymptotes. Don't make it look like it's squished and skinny inside there. It's got to go up towards the asymptotes. And we need a couple of numbers on the other side of 1. Do you see the symmetry in the numbers? So it still has that hyperbolic symmetry going on. one gonna cross our asymptote and go up to 10? The window that we're supposed to track? Nope. Good. Last but not least. Any X's we couldn't use? Asymptotes. -4 and 1. Four, 3, 2, 1, 0. Me feeling your feelings on 8-1 to 8-3 now that we've done some review. All right, I would say it's good we've got another 2 days of review. Yeah, it's coming back to us, just not, especially the horizontal asymptotes. When I looked out, I saw a lot of people kind of going, "Oh my gosh, I totally forgot about the horizontal."
Oh my gosh. Oh my gosh. Oh my gosh.
So you'll get your memories back. You do.
Oh, we do?
Not a worksheet. No. Somebody asked. We
Why
have
should we have
homework.
homework? We don't know what's going on.
Oh, you need practice.
No, we don't. Practice, but we don't know what's going on.
Practice makes
How are we
perfect.
supposed to
That's a
do
lot.
Well, you
honestly.
do know now.
That's a lot of
Just
problems.
needed some review. Oh, and they're
Okay,
horrible.
that's the shortest I've ever
They're
written
just
problems
awful.
for one of the longer assignments.
We should, you know what? We should cut it down like half.
I don't know that there is any practice.
We should go
There
1 to
isn't.
12.
Let me take a peek. It's a lot of what's the vertical asymptote, what's the horizontal asymptote.